Hi guys, this is Mr. Bullock again. This one's going to be solving compound inequalities, and all that means is we're just solving two equalities in one. So a compound inequality is two inequalities joined by an AND statement or an OR statement, and it makes a compound inequality. So when it's an AND statements means the intersection of the two. So we're going to solve them and then where they overlap each other. So here's a real easy example, you guys. If I had x is greater than -2, it would give me this graph, an open circle on -2 and shaded that way. You remember that? Okay, and means I'm looking for the intersection. So let's do this red guy, x less than or equal to -1, or +1, sorry. And then so it's going to go that way. And then and is the intersection right here. So if you see the word and, it's intersection. So we're blue and red mixed together, it's going to give me the purple. So I would get the purple right there. So there's my graph answer right there. It starts at this open circle and this closed circle. And then we'd write them like this, you guys. And statements are always written like this, with the smaller number on the left and the bigger number on the right. See the smaller number here and the bigger number here, and x goes in the middle. Always write and statements like this, where x is in the middle, and you got the smaller number over here and the bigger number over here. Okay, so let's try an or statement, you guys. Or statements, when it's an or statement, it means union, and it consists of shading from either part. And I should underline this stuff right here, you guys. It's shading um, from both parts. Okay, that's the important part. It's shading from both parts. All right, let's try a simple example, you guys. So x greater than or equal to 0. That's a closed circle on 0 going to the right. And if it says or, so you got to watch the wording. This one says or x less than -2. That would be an open circle on -2 going to the left. And then remember the both parts, when it's or, means you're going to get that answer. You just blend them together. You don't have to worry about overlapping or intersection. Or just wants the graph of both of them together. And is where they intersect, or is where they don't. If this, I'll get to that one later in a different lesson there. I was going to say something. Okay, so both parts mean just blend them together. Where this graph comes together with this one, it means both graphs together. Okay, and or statements are always written like this, you guys. You say the left side over here, so x is less than -2, or x is greater than or equal to, because it's closed in, 0. Okay, or statements typically go in opposite directions, and statements typically are going towards two numbers, shaded in between two numbers. All right, let's try solving a couple of these, you guys. So let's solve the inequality and then graph the solution set. Here's the first one, you guys. Okay, remember when x is in the middle, this is an and statement. I need to get that x all by itself. So what I'm going to do is subtract off the 5 right there, and that means I'm going to subtract off the 5 over on the left, subtract off the 5 on the right, and then 2 minus the 5's will cancel. 2 minus 5 is -3, and then over there 9 minus 5 is 4. So here's my graph, you guys. It's going to be an open circle on -3 and an open circle on 4, and x is in between them, so it's going to be shaded in between right there. That's the algebra answer, and then here's the graph answer right there. Open circle on -3, open circle on +4, shaded in between. Okay, see, these aren't that hard. Just compound means you have two inequalities happening at once. Okay, here's another and statement, you guys. So we got 1 is less than -2x plus 3, less than or equal to 17. Okay, just like last time, let's get rid of that 3. You're going to subtract 3, subtract 3, subtract 3. Okay, and then the 3's cancel, and when I do 1 minus 3 here, I get -2. I'm still left with -2x in the middle. 17 minus 3 is 14. Okay, and then we're going to divide by -2, divide by -2, divide by -2. Remember, when you divide by negatives, it flips those inequalities in the opposite direction. So now they're going in the other direction. Now I have over here, -2 divided by -2 is 1. Over here, 14 divided by -2 is -7. So x is in the middle, and then I get that. And on and statements, since this number now is bigger than this number, 1's bigger than -7, I'm going to flip them around, you guys. We always want to have the smaller number on the left and the bigger number on the right. And then so X is in the middle, and when you flip them around, it flips those inequalities back around. Okay, the smaller number is always on the left, and the bigger number is always on the right. Okay, open circle on -7, closed circle on 1, and it's going to be shaded in between the two. There's the algebra answer. There's the graph answer right there. Okay, open circle on -7, closed on 1, shaded. Okay, let's try an OR, and we'll be done with this. Okay, on this one, this is an OR. Typically, not always, and I'll show you examples of not always on the next lesson, but typically OR statements shoot in opposite directions. Okay, typically OR statements. So here, whoops, I'm going to take off. I'm going to take off 3. Solve both of them separately. So I'm going to take off 3 on that one. I'm going to add 6 to that one, and then I get over here. 9 minus 3 is 6. 12 plus 6 is 18. And then I'm going to divide by 2. And on this one, I'm going to divide by 3. And I get x is less than 3 or x is greater than 6. Okay, that would be my algebra answer right there. That's how you write algebra answers with OR statements. You got the smaller one going on the left and the bigger one going on the right, and they go in opposite directions. Open circle on both of them, going in opposite directions.